sketch the curve y equals x cubed minus 4x over x cubed plus 1. It's one of these kind of tricky things that we see from time to time. It's a rational function, but we have to treat them all, we have to take great care. First thing is to look for where does this graph cross the coordinate axes. Well, we can see that it crosses y equals 0 when x equals 0, because x is 0 at the top and gives y equals 0, but perhaps factorising the top would be quite helpful here. Let's do that. So y equals x bracket x minus 2 x plus 2x minus 2 and x cubed plus 1. Now we can see immediately now that the graph crosses at 2 minus 2 and it goes through the origin. Doesn't cross the y-axis apart from at the origin. So that's the first thing. We've basically done that. Next most obvious thing to look for is the vertical asymptotes. Well, we can factorise the bottom. Not really necessary here. We can see that this is equal to the denominator here is equal to 0 when x equals minus 1. So we're going to have an asymptote at minus 1 here. A vertical asymptote at minus 1. I will factorise the bottom just for completeness sake, because in other cases this might be important. So I'm going to factorise the bottom. So we've got y equals, as I say, it's not necessary here, so long as we know that that is the only asymptote. But in order to just verify that, if we factorise the bottom, and it's minus x, I believe. That factorise, actually x cubed plus 1 is a fairly well known factorisation. Now that, as we can see, this quadratic there, if you like, the discriminant is less than 0. It has no real roots, that equation. That's never going to be equal to 0. It can complete the square or whatever to say. So the only asymptote is actually at x equals minus 1 only, but we perhaps didn't need to do this full factorisation that I've spoken for in this case for that. Okay, now next thing, so we've got the vertical asymptotes. Now let's look at the behaviour when x gets very large, i.e. tends towards infinity, or gets negatively large, if you like, tends towards minus infinity. Well, long division may help here. You might just be able to see that the answer is going to tend towards 1 from the actual coefficients of our x cubed at the top here. But let's imagine you don't see that, and we are looking at just the just a process for doing it. Long division will help us. I think if we do a long division of x cubed plus 1 into x cubed minus 4x, that becomes 1. Then we'll get x cubed plus 1. We've got to be careful with coefficients here, but I'm looking at that. The remainder is minus 1. So that makes this y equals 1 minus 4x plus 1 over x cubed plus 1. Okay, now what we see here is that the second bit here must tend towards 0 when x tends towards infinity or x tends towards minus infinity. Why? Well, because the order here, we've got a cubic, which is a much more powerful function than a linear. And that will always be the case. You will see explanations where it's divided through by x cubed, say, to show that it actually does that. But actually, in general, it is the case. We're not asking to prove it here. In general, it is the case that the kind of if the order, if we have an algebraic fraction, if the order is greater, so for example here we've got a cubic above a linear, it would equally be the same if we had a cubic below a linear. If we had a quadratic as the denominator and another linear as the numerator, again that would tend towards 0, because this bottom bit is getting much larger, much more rapidly as x gets large than the top bit. They're both getting larger, obviously, but this one is kind of dominating this expression, so that's going to tend towards 0. So that's telling us that y tends towards 1, because we've got this one here as x tends towards infinity or x tends towards minus infinity. Okay, so what that's saying is that we've got an asymptote, horizontal asymptote, on y equals 1. So let's just put that in here. Okay, I know my scale is not the same, but that's fine. There's no problem with that. Just sense it might be easier to actually do the sketch if I do that later. Okay, so, and my asymptote there is minus 1. Okay, right, now, what else can we find out here? Well, we've got asymptotes, we've got we've got the behaviour, which has given us our horizontal asymptote, so we know quite a bit, but you might be saying, well, I've got some points and some features here, but I still can't sketch it. You might be tempted to differentiate the expression to find for maximums and minimums. I'm not going to do that, because life is too short, and I don't really fancy differentiating that top bit. It is not true that mathematicians like doing things complicated for the sake of it. If I can verify that, by some other means, because I've not asked for the coordinates of the minimum or maximum, if I can find some other way of verifying that there is one through other features, I will do that rather than go through what looks, it may not be that bad, but I still don't fancy the differentiation of this. So sometimes it's worth thinking of that. I'm only going to do that as a last resort. Let's see how it goes. So what I'm going to actually do is actually look at these values. We've almost got critical values here of x, which are minus 2 because of the 0 at minus 2 here, the asymptote at minus 1, the 0 and the 2. So it may be worth looking for what the sign of this function is between different values of the between different ranges. So for example, what does a function do when x is less than minus 2? What does it do when x is between minus 2? Let's not worry about what it is when it's actually that. It's either an asymptote or a 0 value. When x is between minus 2 and minus 1. Is it positive or negative? Well, that's really what I'm interested in. Is it positive or negative between these regions? And then what is it between this and 2, and what is it when x is greater than 2? Let's tidy that up a bit. So. Okay, well, when x is less than minus 2, if I look at this, we've almost got 3. Let's just rewrite that. I've got the critical values. Let's rewrite my function here in factorised form. I'm going to, so that we can see. We've got y equals x bracket x plus 2, x minus 2 over x plus 1, x squared minus x plus 1. Okay, this, as we've already said, this one here is always positive anyway, because if you complete the square, that's always positive. But we've actually got 5 different bits here. Now if x is greater than minus 2, let's look at the signs of all of this. We've got 3 terms on the top. These 3 are all going to be negative. Okay, this is negative. Okay, and we've got a positive, but we've got an even number of negatives for that, so the whole expression is positive. If we look at between the values minus 2 and minus 1, we can see that the first one is certainly still negative, because that's just x, any number. The second one will be positive now, because we're adding 2 to it. So for example, minus 1.5 add 2 is equal to 0.5. But this one's certainly negative, and this is certainly negative, and other one is always positive anyway. Okay, so now we've got 3 of them as negative, and we can carry this process. We're going to find this swap signs, I believe, through all of them, but we better be a little bit more careful. So just check this one. If it's less than 0, then this one's negative, and this one is positive and this one's negative. But now this one switches to positive. Minus 0.5 add 1, for example, is positive and positive, so it goes to positive again. And between 0 and 2, we've got a positive 1 here, a positive 1 here, and a negative 1 and 2 positive, so it's gone to negative. And then finally we can see for the final one all terms are positive, so the whole thing is positive. Okay, so that should be able to help us to sketch our curve, because we now know, let's go up here, we now know, look, go to this curve, is that between 0, when x is less than minus 2, but we've got an asymptote here, going to negative between there and minus 1. Okay, so then between 0 and, we can see we've basically covered these 2 bits now. It's gone from positive to negative, going through minus 2, and the asymptote at x equals to minus 1. And what we've got is it's gone back to positive here, which often it does. Not all asymptotes do that if there's a squared involved, but it's gone to the other side now, and then so it's doing this. But now this is where it comes back to where we said we can see this going into a negative region now. We're now here, but there's no way it's going to have to turn, because we know it's going to come to positive here. It's negative in this region and positive in this region. So we therefore know it's going to have to turn. Now I might not get the actual shape of it exactly right, but I don't think we're looking for that. And so there we have our curve. And I have, thankfully, managed to not differentiate, and I really didn't want to do that. Okay, so I hope you enjoyed that little tutorial on how to sketch out curve. Thank you very much, and good night.